a 911 call to an arrest in about 17 minutes. That's the kind of outcome Garrett Langley says flock safety is enabling, by wiring cameras, drones, and real-time software into how cities respond to crime. He talked through the details on Stripe's podcast, and what's worth your time here is how specific this gets, from search for white Converse sneakers to the very unsexy reason this all works, which is better coordination. Welcome to X-Pulse Digest. By the end, you'll have a clear mental model of what Flock actually built, why the stolen car database is less modern than you'd hope, and why drones might be the most practical public safety upgrade in years. Flock started as a neighborhood science project, and the origin story is darker than the typical "I had an idea at brunch." Living in Atlanta, Langley noticed a pattern that's almost absurd in its simplicity. In some neighborhoods, you can pull 10 F-150 door handles, and a few will be unlocked, and one might even have a firearm sitting in the glove box. If you're trying to get a gun, you don't need movie-level sophistication. You just need teenagers hopping out of a car and checking who forgot to lock up. That happened on his street. A gun got stolen. Police showed up, and, because no one was physically hurt, it dropped to the bottom of the list. The major's request was blunt. "We need a license plate." So an electrical engineer and a Georgia Tech computer science buddy built a camera that did one thing. It tracked every car entering the neighborhood. 30 days in, the data starts to label itself. These cars come twice a day. They clearly live here. Then, one night, a car that didn't belong showed up. After another break-in, that out-of-pattern car became the only real lead, got flagged as a bolo, and within hours police found it, recovered the gun, and made an arrest. The next morning, 5 emails showed up from other neighborhoods asking for the same thing. The early go-to-market was almost comical in a way only local news can be. Every time a case got solved, they'd call the 5 o'clock news. The station loved it because local news loves crime stories, and nobody needs a New York Times feature about a stolen sofa. That loop, "We solved something, do you want to cover it?" turned into their growth engine. What changed the trajectory is that the product fit a very American gap. There are, as Langley puts it, hundreds of thousands of neighborhoods and no real consolidation of safety the way you'd consolidate payments or email. Security systems also tend to do 2 things that aren't actually what you want. They tell you a crime happened, and they mostly protect one household, not the community. The community piece matters because fear travels. Something violent can happen a mile away, and suddenly your spouse changes their entire routine. From there, the company moved from neighborhood camera to selling to law enforcement, and by Langley's numbers, it's now in over 6,000 cities, covering well north of 50% of the U.S. by population. The business went from 0 to about $500 million in ARR in roughly 7 years. He's careful with credit, but he says last year Flock was involved in the clearance or arrest process for just north of 1 million crimes. To do that at U.S. scale, the real product isn't just cameras. It's coordination. Here's the part that sounds like a joke, until you realize it's real. There is a national hot list of vehicles and warrants maintained by the FBI, including things like amber and silver alerts, and Flock integrates with it. But a lot of what actually matters day to day is local, and the national version can lag. Langley describes a Bay Area example. If your car is stolen in South San Francisco, it can get into the Bay Area Flock hot list immediately. Getting into the FBI list can take about 24 hours. Why? Because, in his telling, It's essentially a CSV file sent around on FTP servers. That lag isn't just embarrassing infrastructure trivia. It changes outcomes. In 24 hours, a vehicle can be in another state, tied to a robbery, a shooting, or something worse. A stolen car isn't usually stolen for fun, he argues. It's often the tool for doing other crimes, or a way to avoid using your own car when you do something violent. So Flock pushes the problem toward real time. It also adds a layer of anomaly detection. One example he gives is cold plating. If the camera's AI says the make and model don't match the DMV record, it might indicate a swapped plate. Another is catching the same plate in two places at once, the glitch in the matrix moment that suggests something's off. That's the theme. Not magic, just better speed and better pattern matching, in a system that used to rely on phone calls and faxes. The most futuristic thing in this conversation isn't the camera. It's what happens when the camera is connected to the rest of the city. Flock plugs into 911 calls, and Langley's point is that today a human answers, listens, and manually types everything, millions of times a year. If Stripe routed every lead like that, you'd call it insane. In one case he describes, the system heard an attempted homicide come in. The victim was bleeding in the street, and the only detail the caller had was that the suspect wore white Converse sneakers. Now take that detail and imagine it as a search filter. With Flock OS, the operator can pull in cameras across a city, including privately owned cameras and non-Flock cameras if they're integrated. The operator clicks into a nearby feed, uses a tool called Freeform, and searches the last 30 minutes for anyone wearing white Converse. The system finds the person, pushes video to the nearest officer's dashboard, and the suspect gets arrested. Langley's claim is that the whole loop, from 911 call to arrest, took about 17 minutes, and that without this tooling, it could have drifted into weeks and become a cold case. Then he tells a second story, with a kind of ridiculous detail that makes it memorable. An armed robbery at a Levi's outlet, and the getaway vehicle is described as a white van that looks like a black and blue cow. A drone gets launched with a button, flies at 400 feet, knows what it's looking for, and quietly tracks the van until officers can pin it in safely at the suspect's driveway. The payoff isn't, wow, drones. It's that the response becomes less chaotic, and fewer people get hurt. If you've ever thought drones in policing were mostly a flashy add-on, Langley argues the opposite. They're a cheaper way to do things departments already try to do, with helicopters or high-speed pursuits. One city example he gives is Stark. Average 911 response time was about 7.5 minutes. The drone arrives in 68 seconds. 3 use cases keep showing up. Vehicular pursuits first. High-speed chases are among the most dangerous things cities do, and it's often not the suspect who dies, it's someone uninvolved. In many towns using their drone program, they've ended pursuits. They send the drone instead, track from above, and wait for a safe moment to block the car. Second is triaging 911 calls. By the time an officer arrives, a lot of situations have already de-escalated. The drone can verify what's happening, dismiss calls that don't need a response, and free officers for the ones that do. Third is search and rescue. Add thermal imaging and you can find a missing person at night in a way that used to require a helicopter. But the drone story also has an offense beats defense twist. Criminals use drones too. He describes South American cartels flying drones with night vision over neighborhoods to see if anyone's home before breaking in, and drones delivering contraband into prisons with 10 to 30-pound payloads. Here's the weird part. Even today, law enforcement often can't legally take those drones down. It's FAA airspace, not law enforcement airspace. One sheriff told him that shooting down a drone with a shotgun could mean breaking federal law. Public safety tech is never just engineering. It's always engineering plus the rule book. The controversy around this kind of system isn't hard to predict, and Langley doesn't pretend it's fake. His Steelman starts with a simple observation. You can see street cameras. You can't see the apps on your phone with full-time location services turned on, or the data brokers selling that information for ads. 30 years ago, private companies tracking your location and selling it would have sounded unacceptable. Today, it's normalized, partly because it's invisible. Then there's the explicit trade-off. How much privacy erosion are people willing to accept for safety? He frames driving on public roads as already accepting a world where you have a government-issued plate, and constitutionally, you don't have the same expectation of privacy as inside your home. The guardrails he emphasizes are accountability and retention. Flock stores an audit trail of every action in the system, and he says it's stored in perpetuity and publicly available. Data retention is meant to limit abuse, not eliminate it. Typical retention, he cites, is about 7 days for live video and 30 days for license plate reader data, with longer or shorter periods set by democratically elected bodies. He even argues for a counterintuitive posture. More cameras can be fine if access is restrictive. For example, a short default retention, then longer access only behind a warrant. Legislation matters here, and he calls out Virginia's bill as pretty good in some ways, including a 21-day retention period and mandated audits, while also noting it restricts collaboration with federal authorities. The line that stuck with me is that the worst bills aren't strict. The worst bills are unenforceable. Because if nobody can enforce the promise, it's not really a rule. It's just vibes in legal form. One of the most honest moments in the episode is Langley naming what failure looks like. If the prison population goes up, that's bad, even if you can point to 1 million arrests and call it impact. 1 million arrests means 1 million victims, and a criminal justice system that, in his view, doesn't work well. He keeps coming back to the idea that most crime is opportunism, not evil, and that deterrence is less about harsh punishment and more about whether you'll get caught. That's why he's obsessed with clearance rates. He points to places where violent crime clearance hits 100% and claims violence drops because the calculus becomes binary. You will get arrested. He also describes a safe city pitch, where a full platform comes out to something like $20 per citizen per year. There's a messy second-order effect, too. When one city gets better at solving crime, some of it shifts to nearby cities until they adopt similar tooling. The surprising "what's next" isn't another camera, it's prevention. He describes a thriving cities fund that deploys capital into businesses like restaurants and nail salons in cities that choose to be safe, because "don't become a criminal" lands differently when there are jobs. And he's openly searching for a product idea that gives opportunistic offenders a second chance without increasing repeat crime. If you want the full texture, including how hard hardware really is, from forecasting parts 12 to 18 months out to pulling 77 permits a day and literally digging holes for poles, listen to Garrett Langley on Building Flock Safety on Stripes podcast. It's a rare conversation that makes public safety sound less like ideology and more like systems design, with one uncomfortable question hanging in the air. What if the best crime-fighting product is the one that prevents the crime and prevents the prison sentence too?